Guys, gals, and fellow gender non-conforming pals, welcome back. My legal name is C28. Truly, it is. And we have another nice day of this beautiful Worm Audio 8000. Beautiful mic. Gonna appreciate it. This may be the last video log with it. Might appreciate some other goods that my mate's got in stock for me. Appreciate ya. But yeah, so the last few days of lecture and lab have been all about noise. So to sum up noise, there are two very important types of noise to know about. You have system noise and circuit noise. Circuit noise is noise that is going to be coming from your system inherently. It's just when you turn on your system, it's got it. Now, system noise is noise that is gathered through different systems interacting with each other. So say, for example, if I were to have a patch cable here and I made that thing about 40 feet long and I just had that stretch out, it might pick up some stuff. You know how it could really pick up some stuff? Magnetic induction. Yeah. So let me quickly just fix my noise gate. I think that is too long of a release. We're going to do a little bit longer hold. There we go. On the fly stuff. You won't hear this because this affects the final balance. Yeah, that's better. Yeah, so if you have a power cable and a power cable is running parallel to an audio cable, it's going to inductively pick up that signal from your power. And if it's something like, say, a United States wall outlet, then it's going to be picking up that 60 hertz frequency. So you will have a 60 hertz in the background. And that'll be quite irritating, wouldn't it? Now it could fluctuate. It could be like 59 hertz. It could be 62 hertz. It would be whatever. But typically you're going to find it's pretty close to 60 hertz. So I think 62 is a bit extreme, but like within that range. Yeah. So that's noise that you pick up that typically you get from system noise, but any really cable that has electricity running through it is going to inductively not couple, but it's going to cause an inductive current to be picked up by your audio cable, and thus you will have that picked up. So in Europe, it's a bit of a different frequency. I believe it is, let me check real quick. It is 50 hertz as opposed to the 60 hertz in the US and other places, but primarily the rest of the world uses three-phase power in 50 hertz oscillations. Yeah. So the lab that I missed out on that I didn't shoot a video log for, that one was us doing troubleshooting. So I did get some really good footage of that. What we were doing is we were troubleshooting what's called the crossover. You may remember that being brought up when I was doing the video logs for show production. The crossover is a device that allows you to separate your frequencies into different bands that are more well suited for something like this, your monitor setup. So very importantly, I may have said this before, if you send low frequencies to your tweeter, it will explode. We don't like that. We don't like our tweeters exploding. We like them working the way that they should be. So you should filter that stuff off. But what we were doing is we were troubleshooting, making sure those frequencies are actually coming through or being attenuated properly. So we had about like, I don't know, I'd say like 27 different crossovers, like just rack mount things, broken in different ways, maybe intentionally, maybe not. But we had about 28 or so of those, and they were all just in a little closet. Video here. And all those we just randomly would pick up, test. Okay, did we get it right? Yay! Put it back. Could do another one. And that process looked like this. I think it's input one.
Why are we doing that? Because we want to actually look at the input signal. This is why we have two channels on the oscope, because with channel 1, we're looking at what is going into the audio device. Guess what channel 2 is going to be used for? So if you're seeing like if you're seeing these right now, you want to make sure that this is all calibrated or configured correctly. So on your channel 1, make sure that your large knob, you're on the bottom. Cool. So you probably already found one of the 2 bad outputs.
I'm gonna go to low.
So yeah, now. Your high, you're good. Cool. This is so in mute. So in mute, yes.
It's pretty easy once you got it.
Yeah, but it's the repetitions. Yeah, you just got to do it a number of times and get it locked in. And just think about the setup. You know, you got to get your oscillator to the input, look at it with channel 1, then start testing outputs. User. The first couple times you do it, it just looks like a bunch of spaghetti and you can't make sense of any of it. And then once you start thinking of the process and the order of things, it's those 3 easy steps. Once you have the, the buttons and knobs in the right spots, then it's just a matter of connect the signal, look at it with channel 1, and then test the outputs on channel 2.
Boom, boom, boom.
So you can see what that was like, and it's pretty fun. Nice little process to that. I think I got one of them wrong, and I was saying it shouldn't go, but it did go. I forgot what it was, but the text there tells you, and yes, of course. I did many of them. I just happened to mess up the video on this one, but I didn't feel like reshooting it because I was like, I'll just explain it in the future, and here I am in the future explaining it. Yes. So we did that. That was fun, and we were testing the response with the oscilloscope. So we were making sure that when we had the oscillator, so it's a little device that's the same idea as the oscillators in this circuit here for the synthesizer, just an oscillator. It sends AC voltage to the crossover, and then the crossover is able to either filter that out or not filter that out. And we're seeing, is it filtered out? Is it not filtered out? Is it filtered out and it shouldn't be filtered out? Is it not filtered out, but it should be? And is it all other 4 permutations of that? Yes. So that is what we did in that lab. That was pretty fun. Good to do. And in this lab, we were doing a lot of noise testing. So we did a lot of really cool stuff with the oscilloscope, again, showing how noise is picked up on your system. Now, I don't have a whole lot of audio for you here. I do have one really cool example to show you afterward, which I may or may not have the video from the lab. I don't think I will get it, but that's fine, because I have a live example set up on channel 2. Yes, track 2 rather. So the thing I was talking about with inductively inducing a frequency response in your circuit. Ground loops are a massive cause of this. So if you think about your wall power, right, everything is linked to the same ground. You'll have your outlet here, and then it has a little ground port, this fun bio at the bottom, in the US at least. I think it's actually the same everywhere. They always got the ground on the bottom. But anyway, little ground thing on the bottom. And that friendo is making sure that the current goes that way and not into you through the ground. So it's a lower impedance path back to the source, so that way you don't yes, or get demonetized is the way I should have said that. Staying content friendly here. Now all of those are linked, and they go all the way down to the grounding bus at your breaker station. Breaker box. That's it. Breaker box. So your breaker box has a grounding bus where all those grounds meet, and then they all get to go back to the power company. They don't go into the earth. It's a bit of a misnomer calling it grounding, but that is what it is. So like call it that, but it's not going to the ground. It is picking it up so it can send itself back to the source. That's what that's for. But if you connect 2 pieces together, you've suddenly ran them in parallel. If those 2 pieces of equipment are plugged in, you are now running them in parallel. So the grounding bus, or the grounding wire, that grounding wire will go through in parallel. So you have the ground wire from your wall outlet, and you have the ground signal from your audio. So there's a ground wire in this little shielding thing, and inside of this wire, Actually, I'm not familiar with this particular wire because this has the funky many point situation going on. I imagine it's somewhat similar, but I'm confident with this one. This cable has a little mesh shielding around it, which is the ground. Now, if this were, actually it is in this case, in this very case, yes. So my, let me think. No, it's not because my computer's not plugged in. But say if I were to plug in my matriarch, it requires power from the wall to operate. It requires AC power. So if I were to have that AC power running through here, and then I send it into my auto interface, there is a neutral. And then if I have my MacBook charging, if it was charging at that point, then it would be, actually it's ground lifted. Shoot, that still doesn't work. But pretend for a moment that it was going to a rack mounted system that has the grounding thing in it. Okay. What would happen there is if you have any ground, or anytime the ground wire is used, it would send signal to the normal place you would expect, but also through your devices, which will give you some noise, especially if you have things upstream of you. So think of your outlets as a giant set of Christmas lights, one after the other, one after the other, after the other, in series. They all run that way for the most part. I think, well, let me think about this. We did a lab not too long ago, and I showed you the boxes. Yeah, some of them are in parallel. But for the most part, any separate receptacle is going to be in series. It's going to be before or after you. And if it's before you, well, it's still going downstream, and any fault currents will go through your devices. Now, whether it breaks it or not is a different thing, but the point is it will go through your devices if it has that path. It needs a path. Even if it has a higher impedance path, it'll still take it. So what can you do? Well, one of the things you can do is you can use something like a direct input box to block that. So instead of having the ground from my matriarch pass into my audio interface, what I could do is I could have a DI box set up. So the DI box uses a transformer, which breaks the ground signal. It's not unsafe now. It's still good, but it severs that ground connection in the audio cable. So there's no longer this path for it to take. It stops because it's separated by two inductors. So now it no longer has that parallel path, and thus you don't get signal going through your devices and you don't pick up that noise, which is great. But again, it can also work the other way for you. Like I said, magnetically induced current will cause noise in and of itself. So, simple solution here. Solution one, get your cables away from any source of power, or any cable power. What am I trying to think of? Cables that are providing power from the wall. Get them away from that. That's one option. Second option is just have them 90 degrees. Have them perpendicular to each other. And that'll just have the magnetic fields completely void the signal. It'll not magnetically induce with it. And here is a great example of that from lab.
In parallel, so now these are just running straight next to each other the whole way.
Yeah.
And now I'm just going to cross them 90 degrees like 2 bajillion times. And now I've got no noise.
Wow.
Now I've got all the noise.
That's awesome.
See? So that's why when I tell you cross your power and audio at 90 degrees, that's why. Because of the direction of magnetic fields, when you think about, remember that right-hand thumb rule. Remember this this drawing of magnetic fields? When you have current flow like going this way. So think of, we had a wire running this way.
So as you can see, when you had the magnet perpendicular, it did nothing. Nothing. So that's good. That's what you want. But then when you turn it and it's parallel with the other one, and you have the inductor being parallel, which is what will happen if you have a, what do you call it? Power wire and audio wire. If you have those two parallel with each other, then you're going to pick up that noise that you saw, the little spikes. and you don't want those spikes. Those spikes are noisy and they're not nice for you. I'm trying to think of how else to phrase the stuff from lab. I think what I'll do is I'll just give you all the stuff from lab now. So here are all the videos I've captured from lab that might explain themselves. They may not, but I think the stuff that I've explained thus far helps illustrate the point of what we're doing. But for the most part, we're intercepting signals and we're showing how a resistor will cause a signal to prefer a different route. So we have an oscillator intercepting some of the signals. So you have the oscillator being essentially your noise, and that oscillator will either have more or less of an influence depending on whether that resistor is there. And then we also mess with a capacitor to change how it works as well. But here are those videos.
If you're missing anything or something doesn't work or break. So,
Ground hunt.
once we have all that hooked up, and if you turn up the oscillator real big, notice that we know that we have a 1K square wave playing at like pretty big amplitude, but you shouldn't be seeing a square wave at this point in your audio. And that's because there's no unwanted resistance on ground. So even though we have current on our ground that we just put there with our oscillator, it's not becoming a voltage because remember, it's nothing that we can hear. It exists, but so far our circuit is healthy and it's doing what it's supposed to do, because without resistance, it can't turn into a voltage and we won't hear it. So even though we resistor. Yeah. So now we're putting 10,000 ohms of resistance on our ground.
Look like that.
Look like that. Because you're on sine wave, go to square wave. Bam. Now it looks like that.
Yeah, like that. That's just some chilling. Wait, how you did that?
I switched you from sine wave to square wave.
Where though? Out here. Like, what did you just touch to make this?
Like this, I just did your time. Everybody seeing this on screen? If not, let me know.
No.
No?
See it. Oh, well, that one's good.
You're on sine wave, go to square wave. Not like that. It's on 0. Got that there. It's on here. That's on that. Right here.
You put the resistance between them like this too?
Head here. So here's our input, and then it goes output. There you go.
Awesome. All right.
So now it went away.
Oh.
So why don't we use transformers, excuse me, on everything? Well, one reason is because they're expensive. They're heavy and they're expensive. The heavier it is, the more expensive it is. It's the Jurassic Park.
So hopefully you enjoyed those videos. Gives you a general rundown of what that's like. Yeah. Now another cool thing that we were shown is, and I kind of hinted at this when I was talking about the amperage, when I incorrectly calculated 0.04 milliamps, something like that. And then I was like, wait, no, it's nanoamps. Well, yeah, we play on that idea of nanoamps. They're very stupid small, they don't affect you, but they still send signal. So what we had is, and I'll pull up channel 2 now, and I'm going to temporarily swap from the Warm Audio 8000 to the iPhone microphone for this example here. So I will set you down, my friend, and we will turn your thing down. Cool. So now we are running off of the iPhone microphone. So as you can hear, it changed. Whoa, it sounds all weird when I go over here versus over here. And yeah, because it's the iPhone microphone. Yeah. Not dissing Apple, just, it's not made for that. So I can take this off now. I haven't shot like this in ages. Wow. So what I can do is I can take this instrument cable here and let me turn it up. And you may be familiar with something like this. Look at that. When I grab this, I'm picking up noise. And not just any noise. I'm picking up the noise from signals around me. Watch this. If I touch my MacBook, having fun there, but I'm picking up signals from my MacBook through my body into this audio cable, beep. And I can even grab like a live wire here. Not let me rephrase that. I can grab an insulated live wire and you will hear some changes there. So let me grab, say, the wire that's giving power to the Warm Audio 8000. And you hear it gets louder. Let go, gets quieter. Boom. And it's not just getting louder. It's getting louder with a 60 hertz hum. You hear that? It's a pure tone. This is more chaotic and beep. But when I grab this, 60 hertz. Ooh, very deep tone. So yeah, now not just that, but I should have my music playing in here, and I can pass the signal through my body. Lost things. And that was cool. There was an example in class where we passed it through like two people's bodies, and we're like, hey, give me a fist bump. And then we did the fist bump and it passed the audio. But yeah, actually, what's a more fitting song? Can I pull up Noise? Let's see. Let's play Noise. Noise would be such a fitting song for this. There we go. And now I can... I'm just shorting, or it's not really shorting because I'm doing it intentionally, but I'm connecting the high of this signal to the high of this signal, and that creates a path for it to go down. I have the amps turned all the way up because, again, they're about 2 mega ohms of impedance in my body, or resistance. It's quite quiet, you hear. And if I have more contact, you can hear it a little bit better. But yeah, you could just like play, I don't know, if you want to like have a fun party trick, be like, look at this, look how conductive I am, and you like stick it in your ear and yeah. Now that's gross. But again, you can do that. Yeah. So we're gonna clean that now. Yeah, an example of seeing how that works. So I'll cut now to the, I should have snapped when I actually did it, but I'm going to cut now to the remainder of this video. And I'm back with better audio, of course. So that was a very good example. Hopefully that showed off to you how that could work. Yeah, it's just electricity. That's all it is. There's nothing fancy about it. It's just, I mean, it's fancy in and of itself, but like, there is no such thing as audio electricity and power electricity. They're the same electricity. It's the same stuff. It's all the same. So yeah, as long as it's not like amperage is gonna kill you, you can run it through your body, and preferably just stuff that doesn't like interfere with your body. You can run through your body. Yeah, so there's a fun party trick you can enjoy with your friends. But before plugging random wires in your body, please do a voltage check with like a DMM, like one of these friends. Just check it. Just make sure you're not going to demonetize yourself. Be absolutely certain you don't demonetize by just grabbing live wires, because that's typically a terrible idea. But in this case, I'm confident that the amperage coming out of my MacBook and the differential between that and the audio interface is way less, especially through my body, than the amount I could even feel. But don't take my word for it. Please, just test it. Just test it. It's easy. You can do it. So that about does it for the Full Sail stuff. We got our test coming up. So on, what was it? Wednesday, I believe, we have our final test. There'll be a little review. Got a few more things to go over. I think we got our final test then. Then on Friday, we have our lab final. So we have a bunch of different things we have to do. Pretty much all of the stuff that we've done in lab thus far, we have to recreate. So we'll have to bring in, funny enough, our XLR cables that we made. And mine in this case are, whoops. Mine are permanently attached to a taxiway light. But I was told that's okay. I just still need to bring them in for the grade and the credit for that, just to say that I've still got them. So I'll be bringing those in. Yes, and a few other things. So that is it now for full cell stuff. C2A business. I am working diligently to get Lost Melodies and Unloved Timbers Volume 2 mastered, mixed, completed, sent. Not in that order. So hopefully that process goes well. Control voltages, you should be seeing a lot more progress within the coming days. I do plan to make this thing a March release, which is intense. May or may not happen, but I've been saying that since October. So, you know, at this point, I really need to get this thing out there. Because again, there's that threshold of quality. It is lower quality, objectively lower quality than the stuff I've made past it when I've been producing stuff past it. So when I'm working on fixing these songs that were just little song a day, tiny, funny projects, and I'm pushing them out, I need to do that quickly, because if I start making really, really good stuff like beyond that, I can't really push that out and say, oh, look at this thing I made, because it's outdated. So I really need to be pushing that. But I've updated you on, like, things are hard right now for unexplained reasons, but things are okay. Yes. So there may be a productivity loss here at C28 Music, but we will continue. By we, it's just me for now. No editors yet, but I am thinking about it. I've got one mate I'm thinking about adding on the channel as a editor. So you may get to say hello to a new member of the channel who will be acting as the chief editor, which is cool. Yes. But not confirmed yet. So no rumors, not spreading anything, not saying, hey, look at Darlow over here, our new editor. No, we're not naming names or saying anything yet. I don't have any more updates for you. But I did get my soldering iron purchased. The rest of the station's pretty much all set up. I'll give you a little walkthrough of the equipment I've got. We'll do little projects in the future for the C28 electronics stuff, but it'll still be on the C28 music channel. Because electronics and electronic music are inextricably linked. They're the same thing. Like I showed you. I mean, there's still electricity coming out of it. It's not audio electricity, it's just electricity. There's no difference. So I think it'd be cool if at C28 Music I show off the, what would I say? The principles of electronics behind all of this. So this has definitely been the most impactful class, but this is not the last video log for this class. I'll have one more video log, I think, maybe two, but probably one after it's all done, and then I'll wrap the whole thing up, say like, hey, the class is great, I love this, and this, and why you should pay the heck attention in class. Yeah. So that does it. If you enjoyed today's content, you can, of course, subscribe. And YouTube will happily give you way more videos like this one, and not just from myself, but from other creators too. And if you super duper enjoyed it, you can join and become a Control Voltage. The rank of Control Voltage gives you access to the Discord server, early access to videos like this one, behind the scenes content, and we'll figure out more as we go. Yes. So very fun perks being a Control Voltage, and you know, it's fun doing little stuff behind the scenes with yous. Still trying to get everyone in the loop with scheduling for that members only live. We'll probably do that, say, next month. Seems likely we could do it around the same time I pick the winner for the giveaway. So that is still happening again. Giveaway, 1,000 subscriber special. Go ahead and check that video out, linked in the description. And just comment something. You don't even have to watch the video. Just comment something, and you are entered for a chance to win the SM58 vocal mic and My Beats Studio 3 signed by me. Yes. Shipping all around the world. Yeah. I don't care if you're in Australia. I'll ship it to you. That does it now. So if you have any questions or comments, you can of course leave those in the comment section below, and I'll get back to them. Post them in the space if they're really cool for everyone else to see. And I'll still comment on that comment in the comment section, so you don't have to wait. I hope you all take care of yourselves. God be with you. And goodbye, YouTube. How about that? Nice, we finished.